Hi guys, so today we're talking about writing equations of lines for section 2.4. Our objectives are writing linear equations given a graph, given a point in a line, and the slope of the line, writing equations of parallel and perpendicular lines, and writing equations given 2 points, and also writing a linear model, very simple linear models. Okay, so from Algebra 1, you remember slope-intercept form. We spoke about that last lesson. Also, point-slope form. Point-slope form is if they give you a point and a slope of a line, point on the line, a slope of the line, then you can write the equation using point-slope form. And also, if they just give you 2 points on the line, you can also write the equation by first finding the slope and then using one of the points and the slope with the point-slope formula. So that's what we're going to do in the first few examples. Okay, so here they gave us 2 graphs and they say write the equation of the line. Now if they give you a graph, the easiest thing to do is find the y-intercept and then find the slope and write it in slope-intercept form. So in this equation, or this line right here, the y-intercept is over here, which is at 4. So b is 4. And now we just have to find the slope. Slope is between 2 points. So the closest point on the line from here that I can clearly see is this one. So to find the slope, you just count your rise and run. Okay. So the slope again is rise over run. So it's down 2 units. Down 2 units here. And over 1 unit to the right. So that's positive 1. Okay, so the slope is down 2 over 1. So our slope is negative 2. So to write this equation, we just fill in the slope-intercept formula. Okay, the slope-intercept form formula. So y equals mx plus b. So in this case, y is negative 2 for m times x plus b. B here is 4, so it's plus 4. And that's it. Okay. Likewise here, y-intercept here is negative 1. Y-intercept again is where the line crosses the y-axis. Okay. And then to find the slope, find another point on the line. So if I find another point, for me it looks here like that would be another point. Okay, so you go up 2 and over 1, 2, 3, 4, 5, over 5. Okay, over 5. So up 2 over 5, and so this is b, and my slope would be rise 2 and run 5. So in this case, if I use the slope-intercept form formula, my function will be y equals 2 over 5 x minus 1. Okay, plus b here is plus negative 1, which is minus 1. All right. Then they ask you to use the point-slope formula. They give you a point and a slope, and they say write an equation of this line. Okay, so they give you the point-slope formula, but usually we write the answer in slope-intercept form. So we'll start with the point-slope formula, which is y minus y1 equals m times x minus x1, and they gave us the slope m here is a half. Okay, so this is m, and they gave me x1 and y1 here as my point. So I just substitute these values into the formula. Y minus negative 1 becomes y plus 1, and this is a half times x minus 8. Right? And simplify this, leave that there for now, distribute the half. Half times that will become negative 4, and then take away the 1, and so you'll get y equals a half x minus 5. All right? So point and a slope, substitute them in the formula, and this is slope-intercept form. Slope-intercept form. Okay, so again, another example. They gave you here the slope is 4, and it passes through this point, x1, y1. And again, we just use the point slope formula. Okay, and we substitute things in. So y minus 6 in this case equals 4 times x minus negative 1 becomes plus 1. And so we just do some simplification. All right, add the 6 to both sides. And so we get y equals 4x plus 10. Okay, so use the point slope formula to end up with an equation in slope intercept form. All right, so let's move on there. Example 3. Example 3 says write equations of parallel and perpendicular lines. It's a little bit more work, but since they gave you a line, you really have the slope, so it's almost the same as example 2. It's not much different, just your ability to recognize parallel and perpendicular. In the previous lesson we spoke about that. Parallel lines have the same slope, perpendicular lines have negative reciprocal slopes. Okay, so let's do it in this order. They said A, find the line that's parallel to this line and passes through this point. So this is going to be our x1 and y1 for both parallel and perpendicular, but we're going to use different slopes. All right, so in this case, let's do the parallel line first. Okay, so I'm trying to find the equation of the line that's parallel to this line and passes through this point. So if my line is parallel to this line, the slope is the same, which is 3. The slope here is 3. All right, and then I can use that point for negative 2. So I'll just copy it down here. For negative 2, we call it x1, y1. And so now I have a point, a point and a slope, so I use point slope formula again. So y minus y1 equals slope times x minus x1, and substitute. All right, so y, in this case, y1 is negative 2, so it becomes y plus 2 equals the slope times x minus 4, and do some simplification. Distribute that through there and take away the 2 both sides, and so you end up with y equals 3x minus 14. Okay, so that's the line that's parallel to this line that passes through this point. Now you can check that because the slope obviously is the same. The slopes are the same, they have different y-intercepts. This line passes through this point and it's parallel to the given line. Okay, and so now if we want to do this for perpendicular line, I'll just abbreviate that perp. Okay, perp. The perpendicular line does not have the same slope. The perpendicular line has negative reciprocal slope, so that would be negative 1/3, but we can use the same point again. I'm not going to write it down. Okay, so substitute into the point slope formula. I'm going to do that a little bit faster. So now we have y minus 1, okay, I'm sorry, y plus 2, just like we had here, equals, only thing that changes is now the slope is negative 1/3 times x minus 4, okay, x minus 4. And so simplify this, distribute the fraction in there, negative 1/3 x, this becomes a plus 4/3, okay, and then take away the 2. It's testing your fraction skills again. Okay, so negative 1/3 x. If you combine these two, you end up with negative 2/3. Okay, this is negative 6/3 plus 4/3, negative 2/3. Okay, and so here's our answer of the line that's perpendicular to this line, okay, and passes through this point. You can see the slopes are negative reciprocals, so they're perpendicular. Okay, let's try another one of those. I'll try and speed this up a little bit. Okay, so same exact question. First find the line that's parallel and then the one that's perpendicular to this line and passes through this point. So again, x1, y1. For the parallel line, okay, the slope I'm going to use is the same as this one, which is -3. And for the perpendicular line, the slope I'm going to use is the negative reciprocal of this, which in this case is a third. Okay, and we use the same point both times and plug it into the point slope formula. Okay, because I have a point and a slope. So we substitute that in, and what you get is y minus 1 equals -3 times x plus 2, okay, from here. And if you simplify that, in the end you find y equals -3x minus 5. Right? Very, very similar to the previous example. Again, check yourself, they have the same slope, so they're parallel, but this line passes through this point. Okay? And then perpendicular, same idea, substitute into the point slope formula. So y minus 1, we're using the same point, equals different slope, negative reciprocal slope, x plus 2, just like the previous example. Okay? So everything's the same except the slope is different. And so when you simplify this one, you end up with y equals 1/3 x plus 5/3. Alright? And so again, we ended up with slope-intercept form of the lines. Alright. Then, now they give you a little bit less information. They don't even give you a slope. They just give you 2 points. They say there's a line out there that passes through 2 points. Okay? And you need to find the equation. And again, we're just going to write the equation in slope-intercept form. That's the easiest thing to graph. So we're just going to write it in that form. Now you have to do 2 steps. You can't just substitute and simplify. You always need a slope for a line. So we have to find the slope. So the first thing we're going to do is find the slope. Okay? And the second thing we're going to do is use point slope formula. I have 2 points, and if I find the slope, I have a slope, so I can use point slope again. So first thing you do is find the slope. So you're very good at this because we did this in many lessons now. So the slope here would be -7 minus 5 over 4 plus 2. And so this slope turns out to be -2 if you simplify that. Okay, and now I can pick either of the points. It doesn't really matter which point you pick. Let's just say we pick here x1, y1. Neither of these are easier point than another one. Okay, and so we plug this second step, is put it into the point slope formula. So y minus, in this case 5, equals the slope, which is -2 times x plus 2. Okay, x minus -2, x plus 2. And so if you simplify this, you get y equals -2x plus 1. Alright? Same thing here, very similar. 2 points, you first find the slope, and then you use point slope formula to find the equation. Okay? So find the slope here would be 0 minus 2 over 10 plus 1. And so this slope is -2 over 11. That's a significantly worse slope than -2. Okay, and then second step, point slope form. So y, in this case, I would pick this pair of points to be my x1, y1, because this is 0. Zeros are usually nice because things disappear. Okay, so in this case, I would say y minus nothing equals the slope times x minus 10. Alright, this is nice because I don't have to do anything. Y minus 0 is y, and now I just have to distribute. So you get -2 over 11x, and this becomes plus 20 over 11. And you can leave it at that. You don't have to simplify that anymore. Alright? Example 5. They ask you to write some equations from data. All right, so this is just a little word problem. It says in a chemistry experiment, you record the temperature of a compound to be -5 degrees Fahrenheit 1 minute after you begin the experiment. 6 minutes after you begin the experiment, the temperature is 20 degrees Fahrenheit. Write a linear equation in slope-intercept form that models the temperature of the compound in relation to elapsed time. Okay, so temperature in relation to time. So temperature, these two here, temperature here would be our y value or our output, and time would be our x value or our input in this case. All right, and they did actually give us some values here. They said 1 minute and 6 minutes. That's the time. So that's our x value. Okay, and they gave us, let me pick a different color, -5 degrees and 20 degrees. And so those will be our y values. Okay, so you can actually make data points from this. So in the first case here, I have 1 minute for my x value or time, and then the temperature here would be -5. Okay, so this is like 1 point, and then the second point would be this, would be 6 for x or for time in this case, and 20 for temperature. So my second point would be 6 and 20. So they really gave us 2 points, 2 data sets, even though it doesn't really look like that. But when they say the temperature of the compound in relation to time, they're really asking for an equation that is T equals something to do with time. Okay, well, that's a bit confusing. So temperature equals some relationship with time. Okay, that's basically what they're asking for. Come up with an equation that relates temperature and time. And so we have 2 points. So again, it's basically identical to example 4. It's just that you have to figure out these 2 numbers yourself. And so we can just do that again. So first find the slope. We have 2 points, so we first have to find the slope. And if you do that, you get 20 here. I'll take that as my y2, minus -5, which becomes +5 over, and then 6 minus 1. Okay, 6 minus 1. And this is degrees, and this is minutes. Right, so minutes is my x, degrees, temperature is my y. And so your slope here turns out to be 5 degrees per minute, if you simplify this. Okay, 5 degrees per minute. So that's my slope. And so now the second step again is use point slope form. Okay, and substitute things in. So pick either point. And I would pick this one probably because the numbers are a bit smaller. Doesn't really matter. So y minus, if this is my point I use, y1 would be y plus 5 equals the slope of 5 from here times x minus 1. Right? So this is my x1, y1, that's my slope. Plug it in here, and if you simplify this, which is something I know you're good at, you get 5x minus 10. So y equals 5x minus 10. And you can check that by plugging these numbers in and seeing if they work. Okay? And we've done that already, they definitely work. So this is the function that relates temperature and time. So y here stands for temperature, x stands for time. Okay, in minutes. All right, one more, actually almost a little bit of an easier question, but now they're asking you to write your equation in standard form. All right, so it says you have $6 to spend on a drink and a salad at the school cafeteria. The drinks cost $1.25 each, and the salad costs $20 per ounce. It's some expensive salad. 20 cents per ounce. So it's a salad bar where you can just take as much as you want. Okay? And so write an equation in standard form that models the different combinations of drink and salad you can buy. So you can first set this up in words. You can say my spending on drinks. Okay, so I'm buying drinks and salad. My spending on drinks plus my spending on salad okay, must be equals to the total amount I have to spend, my total spending. I can't spend more money than I have. Okay, and so spending on drinks, let's say D is the variable for drinks. Spending on salad, let's say S is the variable for salad, would be 125 times how many drinks I buy. So you are familiar with that little setup, 125 times D. Okay, that's the spending on drinks, plus spending on salad is 20 cents per ounce. So it would be 0.20 times S for salad, ounces of salad. Ounces of salad, number of drinks, okay? And that must be equals to $6, or maybe even less than or equal to $6, but we're doing linear equations, so equals $6, okay? So there's my equation that models the different combinations of drinks and salad I can buy to get me to $6. Okay guys, we'll look at this in class next time and maybe do some linear equations on the computer. Thank you.